Alright, page 12 of the C programming notes, and section 7. We're going to talk about how your program is organized in memory when it gets loaded and is running. So this is program memory layout. And so we're going to start with the diagram here. Right in the middle I will have the text segment, and below that the data segment, below that the heap, and the heap is a structure that grows in size and it's going to grow this way. I'm going to skip a line, and at the very bottom is the call stack, which is going to start at the bottom and it's going to grow up towards the heap, and you hope that they do not meet. So I'll put a dashed line between the stack and the heap, since they're not really a true boundary, they're just growing in that direction. And the text segment is starts at low memory addresses, so this is what you call a memory map, and I am putting the lowest address at the top. Sometimes you'll see it flip the other way. I think it's more common to have it oriented the way that I've got it here, and I find it more intuitive. So these hex addresses, they're 8 digits, that's 32-bit addresses, and that's from the lowest address to the highest address. Okay, so the text segment, I've mentioned this before, it holds the instructions, the machine instructions, and the text segment is often read-only if the processor supports that. Memory that we're using in the lab for text segment is actually the flash memory, and you can't really write to it while you're running. That would do strange things, so it is effectively read-only. The data segment is used for global variables, so all of the scope of a global variable is the entire source file. And then we have static variables, which you may not have seen before. We're going to look at those when we talk about reentrant functions in the I/O section of the notes. But a static variable has local scope, so it's inside a function, but it has static duration. So that means that the memory that's allocated for that variable doesn't go away between function calls, and it remembers its value. It's probably a new concept, maybe a little strange, but it does have its uses. Okay, the heap is used for dynamically allocated data. So when you malloc something, or in C++ if you knew something, it's coming from the heap. So dynamically allocated memory. And then the stack is the call stack, and it has everything to do with functions. So it's got your local variables and your function parameters are usually stored in the stack. If you do assembly programming with functions, you'll learn that you actually have to you need to store the value of any registers that you're going to modify, and then restore them before you leave that function. Otherwise you'd mess with the function that called you, and the place you do that is in the stack. We're not going to do that in this course. Okay, the next example here is I'm going to just give you a short little program that demonstrates these different segments being used, not the text segment, although I guess I could do that too. but the other ones. It's not going to fit all on one page, so I'm going to end this one early, and then we'll start another page.